Today we're doing composition functions. We did composition functions when we talked about trig, and it was where you evaluated one function. It kind of gave you the answer that you put into the next function that we did. So to make composition functions is to, so to say, combine more than one function. So two or more. Combine two or more functions. So typically in this class we will only combine two functions, but you could take two functions and do it into a third function, into a fourth function, etc. You can take the logic of how we do it for two functions and apply it to as many functions as you have. So these are our basic operations of functions. We know we can add things, we can multiply things, we can subtract, and we can divide. We can do all of those things with functions as well. Adding two functions is just taking the f function, the first function, and adding it to the second function. This one is typically not that bad for you to do. The second one, when you subtract, in the past I've noticed that subtraction of functions is actually one of the most commonly missed, and it's due to the fact that this minus sign, it is function f minus function g, meaning that this minus sign right here does need to get distributed. So I'm going to distribute the negative. And so I'll show you that example in a little bit. The other two operations is multiplying. So you can take your f function and multiply it times your g function. This is probably the other kind of difficult task because this would involve a lot of foiling or distribution as well, really. So you have to be careful with the multiplication, because you will have to FOIL all of f times all of g. And while divide sounds like it's going to be hard and even kind of looks like it's going to be hard, the division is actually the easiest one because there's nothing really we can do to simplify, or at least it's not the purpose of this class or this unit. So we won't actually be simplifying f over g very much. Alright, so let's do a couple of examples. We have f of x is 3x minus 2, and g of x is x squared minus 5. We want to find the following. And when you find it, you are going to want to simplify as much as you can. So when I think about f plus g of x, it makes more sense to me to think of f of x plus g of x. It just seems more obvious as to what it is that I am doing exactly. So I take that f of x function, in this case f of x is 3x minus 2, so this is our f of x. And I'm going to add it to g of x, which is x squared minus 5. With addition, I don't really worry about parentheses that much, but if you want to get into the habit of always using parentheses, I think that's a good idea because for multiplication, parentheses is a big deal, and for subtraction, those parentheses are a big deal. The only reason why it's not a big deal here is because if you distribute a plus, that doesn't really change anything. But at least you can keep that consistent with how you do it. Okay, so if we want to simplify this, when you simplify, I would prefer that you write it in the correct order. The correct order is high degree is written first, second highest degree third, and so forth down the row. So x squared is the highest degree that I have, so I will write that first. The next highest degree I have is just a simple x, or 3x, which is positive, so plus 3x, and then the negative 2 and the negative 7 combine to minus 7. I am not expecting that you factor or do anything past this point. This is the final answer I'm looking for. We'll do that later. No. No, it'll be next week after the test. Y'all's test is Friday. Okay, let's do B next. So, B is our subtraction, and this is the one that you really have to be careful with, because when you do, remember the f minus g of x, if you would prefer to write it, and I certainly do, as f of x minus g of x, it really makes more sense to what to do or what that means. So f of x is 3x minus 2 still. And I am going to subtract g of x, which is x squared minus 5. Now this is written incorrectly, because as you would read this, how I've written it right now, is that it looks as though it's only negative x squared, and that is not correct. It is really important that you say, I have to minus this entire thing, because this is g of x, and g of x is getting subtracted in its entirety. And if you want to put this one in parentheses, that's certainly not going to hurt anything. More parentheses is better than not enough. So the purpose of these parentheses right here is so that you make sure to distribute that negative. So what happens when you distribute that negative is this becomes negative x squared, negative x squared, and then negative 5 makes plus 5. There's really nothing to distribute for this parenthesis, so I'll just write it again. 3x minus 2. And now I'll combine like terms again, going in descending order. Negative x squared is the first largest degree, so negative x squared is first. There's still only one x term, it's plus 3x. And this time I have negative 2 plus 5 makes positive 3. And that would be your final answer. Yes?
Did you do x squared minus 3x?
No. Any questions? Okay, let's do the next one. F times g of x. Once again, I would take the time to rewrite that as f of x times g of x. So, this is too thick. What that means is we take our f, which is 3x minus 2, and we multiply it times our g, which is x squared minus 5. Once again, I am showing you the incorrect way to write this. If you look at how I've written it right now, it appears that the only thing that's getting multiplied is the 2 and the x squared, and that is not correct. It is that this 3x minus 2 is multiplying times x squared minus 5. So once again, I'm going to insert those parentheses, which is really going to make it clear that I must FOIL. So when I FOIL this, I do 3x times x squared is 3x cubed. And then I do 3x times negative 5 makes minus 15x. Negative 2 times x squared is minus 2x squared. And negative 2 times negative 5 makes a positive or plus 10. And even though there's nothing really to combine here, I really do prefer that descending order. So first was still the 3x cubed. That's written first already. But I need to make this negative 2x squared next. Minus 15x is the third. And 10 is last. I don't think I would take off if you didn't put it in descending order, but it would certainly make me happier when I am grading, and that should be better for you. Okay? All right, let's do the last one. F divided by g of x. Once again, that is the same thing as taking f of x over g of x. It's just a different preference of how to write it. Once again, f of x is 3x minus 2 divided by g of x, which is x squared minus 5. And really, that's all we can do. Again, I think parentheses are helpful here, because if you put parentheses in here, it really reminds you of how you simplify fractions. You only simplify a fraction top and bottom if the group 3x minus 2 is the same top and bottom, which they're not. So there is no way to simplify this at all. Later on, we'll get to talking about what is the domain for this. We've already kind of done problems like this. We would say, okay, the top is fine because it's linear. That'd be all real numbers. The bottom is fine because it's quadratic, but x squared minus 5 can't be 0, and you'd go forth from there. You do know how to do this already. It's just not really the focus on today, so we're not going to talk about it that much today. So once again, that is your final answer. There's nothing else we can do to that. That's why division is really kind of easy, because you really just write it and you're done. There's rarely anything you can do with it. Any questions? Okay. Let's talk about composition of functions. So composition of functions is where you actually put them together. You put them into each other. Following PEMDAS always tells us to do parentheses first. And so you're going to start with the most inside of the parentheses. So here this reads f of g of 3. You can't really do anything with just the 3. So instead, we're going to focus on the g of 3. And that is what we are going to do first. We're going to take g of 3 and evaluate it. So we come up to the top. G of x is square root of x. So if I'm trying to do g of 3, that means instead of x, I should have a 3. So g of 3 is simply square root of 3. Yes? So what we've done so far is we've evaluated this part. We haven't touched that outside f yet. So instead of writing g of 3, I know that g of 3 is equal to the square root of 3. So I still have to evaluate f of, and now I'm going to plug in square root of 3 instead of g of 3. So equals. I go up to my f function. F of x is x plus 4. I don't have f of x. I have f of root 3. So instead of x here, I'm going to put a root 3. So root 3 plus 4. If you could simplify, you would, but this does not simplify anymore. So root 3 plus 4 is your final answer. Please notice that my radical definitely stops at the root 3. There's no question that that top bar stops at the root 3. Do not be careless and just do a big square root and make it hard for me to tell if the 4 is under the radical or not. When in doubt, I assume incorrectly. Okay? All right, let's practice again. G of f of negative 2. So once again, we take the most inside f of negative 2. We evaluate that first. So now I'm looking at the f function, and I'm plugging in negative 2 for my x. So f of x is x plus 4. F of negative 2 is negative 2 plus 4, which is 2. When you can simplify, you will. So I am going to replace f of negative 2 with regular 2, just a 2. So now my job is to say, what is g of 2? So I look at my g of x. G of x is root x. I have g of 2. So instead of an x, I have 2. So root 2. If it was like the square root of 4, yes, you would simplify that to 2. But this is not something that you know. I mean, it's a decimal. It's not something that you would know by things that you know. That's not the right way to say that, but you get what I'm saying.
Not like a common square root.
Yes, not a common square root. Thank you. Okay, we're going to skip the next one because it's just really the same thing, and I want to make sure that we get down to the second page. Oh yeah, I do this.
Slide 1 and 2.
Okay. Is that what yours looks like?
Yeah.
Okay. All right, so if f of x equals x plus 4 and g of x equals square root of x, we want to find the following. So example D is really just like the ones we just did, so let's go ahead and do that one. We start on the inside, f of negative 5. And we evaluate. So looking at the f function, f of x is x plus 4. Instead of x, we want negative 5 plus 4, which is negative 1. So now instead of f of negative 5, I'm going to replace that with the answer of negative 1. So I'm going to do g of negative 1. So now I'm looking at my g function, and g of x is square root of x, so I have g of negative 1 is going to be square root of negative 1. Our focus in here is composition functions. I would accept this as a perfectly fine answer. Can anyone give me maybe a better answer? I. If you wrote I would certainly count that right. It might even be a secret bonus point in there. But I would not say square root of negative 1 is wrong. It, for our purposes, is correct. We haven't even talked about I. So if you remember that from Algebra 2, that is fantastic.
Would it just be I, or would it be like root I? Or no, that one.
The definition of I is square root of negative 1.
Okay.
Okay, E and F. E and F are kind of the harder problems. First of all, let me start with E. E is, I don't know why, but they made up another way to write it. This reads f of g. I don't like the way that this reads as far as how you see it. So I always take the time to just rewrite it as f of g. And are we evaluating this with a number? Like this one, we evaluated with the number of negative 5. If you are not told a number to evaluate, you're just doing the general form, which is x. Yes. So, if you're not really evaluating, that means that you're not plugging numbers in and simplifying. You're just taking that inside thing, which in this case is g of x. And even though this is, I mean, you can just look up here and say, what is g of x? It's the square root of x. I'm not plugging anything in for x. I'm physically using x itself. So g of x is still the square root of x. So instead of this inside the parentheses, instead of writing g of x, I'm going to say that's equal to the square root of x. So now my job is to say, what is f of root x? What did you say?
Just like square root over just the x plus 1.
Yes. So now, if you look at your f function, it's up here. X plus 4 is our f function, but we're not doing f of x like this is showing. We're doing f of root x. So instead of a regular x, instead of this regular x, we need to use root x. But we will still be adding 4 to that. So it is root x plus 4. You're replacing, instead of this x, you're saying I want to use root x. So root x plus 4. And we cannot simplify that anymore, so that is the composition function for f of g. Okay? All right, now let's go the other way. Notice this is g of f of x. You could have seen this written as g of f, but that's the way that I don't like, so I certainly wouldn't rewrite it like that, but this is the same type question. If you see this, you're doing this. This just makes a lot more sense visually as to what you do. So we take that inside thing, which is f of x in this case. We look for our f of x, and we're just going to say, well, that's x plus 4. I'm not evaluating it, so it is still x plus 4. So now instead of writing f of x on the inside of those parentheses, I'm going to write x plus 4 on the inside of those parentheses. So now I have g of x plus 4. You okay? Okay. So now I go to the g function. G of regular x is square root regular x. But I don't have g of regular x. I have g of x plus 4. So instead of just having an x here, I want to have x plus 4 there. So I still have that square root, but instead of just an x in my square root, I have x plus 4.
Would you not square root the 4 and it would be square root of x plus 2?
Okay, when you are thinking about square rooting the 4, you are not thinking of radicals correctly. Let me see if I can. Okay, I do want to again point out the difference between radical x plus 4 versus radical x plus 4. You need to understand that when I stop the bar here, I'm saying you only take the square root of x, add 4 to it separately, as opposed to adding 4 and then taking the square root. These are completely different things, and it needs to be clear to me which one is your answer. Okay, example 3. Example 3 takes a little bit of time to go through because there's actually 2 ways to do it. And for about half of you, you'll like the way I like, and the other half may like the other way. So I am going to show you both ways, but you don't have to do both ways by any means. You say, okay, I like the first way she did it, that's the way I'm going to do it, or the second, okay? So I'm going to split this down the middle. I'm going to do it one way on the right, one way on the left. The way that I prefer is consistent with how you did it on the front page. If you flip it back over to the front page, when we did the front page and you had a subtraction question, I'm talking about subtraction because this is subtraction, we subtracted f of x, we subtracted g of x. And that's what we did, and we distributed the negative sign and so forth. The only difference between that and this is that you're also going to evaluate it at 4. So if you do it that way, in my opinion, it's easier because it's keeping your rules consistent. So how I would choose to do this is I would say, what is f of x minus g of x? And only after I do all of that work right here, then I would say, okay, now what is x at 4? So it's kind of like a 2-step process, but at least this way I know what to do every time I see subtraction. So let's do it this way first, and then I'll show you the other way. So f of x is x squared minus 4. G of x is x plus 3, and I'm subtracting. So what do I need to make sure I include here? Parentheses. If you want to put it here, you can, but what's really important is that you put parentheses on the subtraction one. So what this really means is that I have x squared minus 4 minus x minus 3, which is x squared minus x minus 7. But I still have to evaluate, don't forget this 4 is saying evaluate it for x equals 4. So I'm going to plug in a 4 here and here. So that is 4 squared minus 4 minus 7 is 16 minus 4 minus 7. 16 minus 4 is 12. Minus 7 is 5. So we get 5 for that first way of doing it. Okay, the other way to do it is, I will admit, probably easier. But if you do it the other way, the problem is that then you're remembering, okay, sometimes I do it this way and sometimes I do it this way, and that's the part that I don't like. But mathematically, this other option is easier because all you do is you take f of 4 and then you subtract g of 4. So f of 4. We go up to our f function. It's x squared minus 4. So that's 4 squared minus 4, which is 16 minus 4 is 12. Then I take g of 4. So I'm plugging in a 4 into my g. So that's 4 plus 3, which is 7. But don't forget that we are subtracting those things. So 12 minus 7 is 5. Notice we get the same thing. Again, I understand that this way is easier, so if that's the way you want to remember it, that's just fine. Don't do them both ways. Well, unless you want to check, which is probably a good idea. But you don't have to do them both ways. All right, you already have your homework, so unless there's questions, are y'all good?
I think the school is on.
Great. Okay. If you have the square root of x plus 4, this is simplified. What you are thinking about is the square root of 4x. That is, the square root of 4 is 2 radical x. But it's kind of like when we talk about fractions, how you can only have multiplication on top and multiplication on bottom to simplify. It's that same rule for radicals. You're asking if you can simplify it to this, right? No, plus 2?
Yeah.
Just take a number. Let's say x equals 1. If you plug in 1 here, 1 plus 4 is 5. Square root of 5 would be this side, right? So if these were in fact the same, that should be the same. If you plug in 1 here, the square root of 1 is 1, plus 2 is 3. So multiplication simplifies almost always. Addition and subtraction is really, really hard to simplify.